Okay, so here is our first example. Now, as we get started on the first example, I want to explain to you, and I want to give you a real life problem that this could go with. So let's say that you either, an architect, or maybe someday you want to be an architect. Okay, what architects have to do is, let's say that I am the architect, and I found a piece of property that I want to build a building on. So I know the dimensions of the property and everything that will help me understand what I can put on there. So what I do is I make a small scale drawing of the building that I want to put on it. Now I want to get extra funding for this property or for the building. So what I do now is I make a scale model, AKA another scale drawing of this that's slightly bigger so that I can take that in and show the people that might invest in my building. Okay, so finally, after I have my original small scale drawing, then I have my scale model, which is a bigger scale drawing of it. Finally, I build it, and that's the actual size. So take a look at this problem right here, and this is kind of what we're talking about. So I'm going to read the problem. An architect makes a scale drawing of a recreation center. The scale from the actual center to the drawing is 6 meters to 1 centimeter. Make another scale drawing of the pool using 5 meters to 1 centimeter as the scale from the recreation center to the drawing. So I read it through the first time. Now I'm going to reread it another time so I can start pulling out important information. An architect makes a scale drawing of the recreation center. So this is the recreation center right here. Here's what I know about the scale drawing. The length is 5 centimeters. The width is 2.5 centimeters. That's pretty important. The scale from the actual center to this drawing right here is 6 meters for every 1 centimeter. So what that means is for every 1 centimeter here, in real life, it's 6 meters. Okay? And then finally, here's what I'm expected to do. We're going to make another scale drawing of the pool using a scale of 5 meters to 1 centimeter for the new drawing. Okay, so the very first step that we have to do is, so here's our first, might be helpful if I spell it right. Our first step is to find the actual dimensions. So the very first step that we need to do is we need to find the actual dimensions. So in order to do that, I'm going to take my scale and I'm going to write it as a ratio in fraction form, the fraction form. Okay, so there's my scale. Remember, 6 meters is the actual dimensions, and the 1 centimeter is what it is on the scale drawing. Okay, so let's start out and let's find the length. So to find the length, we're going to write another ratio with the length of the scale on the scale, which is 5 centimeters. Now, like what we already discussed earlier, when finding the actual, remember we multiplied, because look, what do you do to 1 to make it equal 5? We multiplied it by 5. Whatever I do on the bottom, I have to do on the top. So I'm going to multiply the top by 5. 6 times 5 comes out to be 30 meters. So my length is 30 meters. Now let's find our width. So again, we have to use the same scale, 6 meters to 1 centimeter. And we're looking for the width. Okay, so here we go. Our width is 2.5 centimeters. So now you ask, what do I do to 1 to make it 2.5? I multiplied it by 2.5. So whatever I do on bottom, I do on top. So this comes out to be 15 meters. Now I realize that you guys probably, a lot of you guys looked at this and said, well, Mrs. Parkin, hello, this is half of this. So if this is 30, this has got to be 15. I get it. But like I said, I want you guys to see how we use the scale factor and the given information to find the missing piece. It was important to me that you guys saw that. Okay. Okay, so now that we have our actual dimensions, so our length is actually 30 meters and our width is 15 meters, now we have to draw a new scale drawing. And to do that, we have to use the original lengths of it, or the actual lengths of it, in with this new scale. So next step is to use the actual dimensions with the new scale to find the scale drawing. Okay, so here we go. So our new scale, the actual is 5 meters to the scale drawing, which is 1 centimeter. So we're going to start with the length. So the length is right here. The actual length is 30 meters. We're trying to find out what it would be on our new scale drawing. So remember what we did. We're looking for the new scale drawing. So we need to find out, what do you do to 30, right, to get it to 5? So we're going to divide 30 by 5, and we get 6. So 30 divided by 5 is 6. So what that means is we're going to take this 1 centimeter and multiply it by 6. And that's our new length. Our new length is 6 centimeters. Now let's do our width. So we use the same scale. We know the width is 15 meters. Since we know the actual amount, we're looking for the scale drawing, we divide. So 15 divided by 5 comes out to be 3, right? So 15 divided by 3 is 5. So now working the other way, 1 times 3 is 3. So our width is 3 centimeters. And there's the dimensions of our new scale drawing. Okay, so on page 24, number 6, the drawing at the right is a plan for an apartment. The length of each square on the grid represents 1 centimeter. The scale from the apartment to the drawing is 8 feet to 1 centimeter. Draw another scale drawing of the apartment using a scale from the apartment to the drawing of 4 feet to 1 centimeter. Justify why your drawing is accurate. Huge problem, right? Huge. There's a lot of stuff going on. So what I'm going to do is I'm going to read back through it, pulling out important information. So the drawing at the right is a plan for an apartment. Okay, got it. The length of each square on the grid represents 1 centimeter. So you ready? With that piece of information, I'm going to stop and I'm going to go over here. So this is 1 square, 2 square. So this must be 2 centimeters. Okay. This side, 1, 2, up 2 centimeters. This side, 2 centimeters. This side is 3 centimeters, 4 centimeters, and 5 centimeters. All right. So that's what my scale looks like. Okay. Now, moving on. The scale from the apartment to the drawing for this one is 8 feet to 1 centimeter. All right. So I'm going to ignore the rest of that right now, because as soon as they gave me that information, it's allowing me to find the actual dimensions. All right. So bam, right away. So again, like I said, first, we're going to find the actual. All right. So to find the actual, we're going to use this scale. So what this means is for every 1 centimeter in real life, that length will be 8 feet. Now, before we had to do all of the dimensions, but for this problem, I'm going to pick just one of these to find. So I'm going to pick this side right there, and I'm going to find the actual dimensions of that. Okay, so I know that that is 2 centimeters. So 1 times 2 is 2. Therefore, 8 times 2 is 16 feet. So what we just found out is that this side right here is actually 16 feet. Now, I could go through all of them and say, oh, well, then that's 16 feet. This is 16 feet. This side, 3 times 8 would give us 24 feet. This side would be 32 feet, and this side would be 40 feet. Okay, I could go through and do that, but I don't have to, not for this problem. Okay. Okay, so now that we know one of the side lengths, we're going to be able to use that with our new scale to find out what the dimensions of the scale drawing will be. So if we go on to this, it says, draw another scale drawing of the apartment using a scale from the apartment to the drawing of 4 feet to 1 centimeter. All right, so next, we're going to find the scale drawing using the new scale. Okay, so my new scale is 4 feet actual to 1 centimeter scale drawing. All right, now I'm going to, the only thing that's going to help me, all right, to find the new scale drawing dimensions is I have to use this piece of information, the actual length of that. So 16 feet. So now I'm going to look at this and I can say, well, 16 divided by 4 is 4, but you guys probably looked at this and said, well, 4 times 4 is 16. So 1 times 4 is 4 centimeters. Okay, so my new length, the one that's just like this, the top one like this, is 4 centimeters. Okay, so over here, what I'm going to do is I'm going to draw 4 centimeters, which is 4 of these. 1, 2, 3, 4. So that's 4 centimeters. And remember, in the original scale, 2 centimeters was 16 feet. Well, in the new scale, 4 centimeters, it's still 16 feet. All right, the actual doesn't change. Now, to figure out the rest of them, well, these ones right here are going to be pretty easy to do because this one is also 2. So I'm going to go down 4. 1, 2, 3, 4. This one is also 4. So 1, 2, 3, 4. Now, before I draw the other ones, my question to you is this. Okay, if you look, this one was 2 and this one was 4. So really, that it's doubled. Okay, so from the first scale drawing to the next scale drawing, it looks like it doubled. So with that being said, if this is 3 centimeters, then that means this side's going to be 6. 1, 2, 3, 4, 5, 6. If this is 4 centimeters, this one's doubled, so that's 8. 1, 2, 3, 4, 5, 6, 7, 8. And then if that one's 5, this side over here has got to be 10. Okay? So there it is. All right. What we've done is we've just drawn a new scale drawing based on a new scale. All right, so here we go. Last problem of the day. Well, of the notes. The perimeter of a pool is 150 meters. The rectangle at the right is a scale drawing of the pool. The length of each square on the grid represents 1 centimeter. Draw another scale drawing of the pool using a scale of 25 meters to 2 centimeters. Then explain why your drawing is accurate. Okay, so I read through it. Now I'm going to reread it, pulling out the information that I need. First, the perimeter of the pool is 150 meters. Okay, this is very, very important. Perimeter and pool. Hopefully you guys remember that the perimeter is the distance around any shape. Okay, now keep going. The rectangle at the right is a scale drawing of the pool. Okay, the length of each square on the grid represents 1 centimeter. All right, so I'm going to stop because this is important right here. So if I go through and look at this, and if I know each square is 1 centimeter, this top one is 5 centimeters. That means this bottom one is 5 centimeters. Okay, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 centimeters. That means that this is 10 centimeters. Okay, so there's my dimensions. Now, here's the problem. In all of the other problems that we had, they gave us the scale. They do not give us the scale for this. So the first step that we have to do is we have to find the scale. So to find the scale for this, we need 2 things from each of these, from the actual pool and from the scale model, that we can kind of compare. And if you look, they give us the perimeter. So what that means is we need to find the perimeter of the drawing. So perimeter is distance around. So 5 plus 10 plus 5 plus 10, my perimeter is 30 centimeters. So here's our scale. If the actual pool is 150 meters, okay, that means, and our scale drawing is 30 centimeters. If I reduce this down, it's 5, because 150 divided by 30 is 5. So what that means is for every 5 meters on the real pool, it's 1 centimeter on the scale drawing. All right, so now that we know our scale, what we're going to do is we're going to find the actual dimensions of the pool, because we're going to need those to draw our new scale drawing. So second, we're going to find the actual dimensions. All right, so to do that, we're going to use our scale. 5 meters is to 1 centimeter. And here's our length. We're going to find our length first. The length is right here. And our length is 10 centimeters. So 1 times what is 10? 10. So whatever I do here, I do here. So that becomes 50 meters. So our length is 50 meters. Okay, now let's find our width. Okay, so 5 meters is to 1 centimeter. That's our scale. And our width is this piece right here, which is 5 centimeters. So 1 times 5 is 5. So 5 times 5 is 25 meters. So there's our width. Okay. So now that we know what our original scale was, which we don't need anymore. We know what our actual dimensions are. These are our actual dimensions. So we know in real life, this right here is 25 meters. And this right here is 50 meters. So we're going to take that information and we're going to use it with our new scale. And our new scale is 25 meters to 2 centimeters. So finally, we are using the actual with the new scale. Okay. Now we got a little problem with this. 25 meters over 2 centimeters. No thanks. Nope, nope, nope. I always want you to have a 1 on the bottom. Trust me, trust me, trust me, it will help you. So we want to get this so it has a 1 on the bottom. So what you have to do is you have to divide 25 divided by 2. And so here's your scale. Here's your scale factor right there. There's your scale. All right, so now here we go. Let's find our length. We know that our length is 50 meters. We don't know what the new scale drawing length is going to be. So to figure that out, we're dividing. So 50 divided by 12.5 equals 4. Okay, and how I know that is because I've done it 3 times today, but I'll show you on a calculator. 50 divided by the scale of 12.5 comes out to be 4. So that means 1 times 4 is what your new length is going to be. Now let's do our width. Same thing. We use our scale right there. And now we know our width, the actual width of this pool is 25 meters. So just like what we did here, we're going to take 25 and divide it by 12.5. So 25 divided by 12.5 comes out to be 2. So if this is dividing by 2, if we go the other way, we're timesing by 2. So our width is 2 centimeters. So now that we have both of those pieces, we can now draw it. Okay, so our width is 2, 1, 2. Our length is 1, 2, 3, 4. And ta-da! Congratulations. So you made a scale drawing of an actual pool that has these dimensions.